polynomials and we want to divide this expression by this expression. Okay, so we've kind of done this before. We've got rational expressions by doing this, but we actually want to divide and do like long division on this. So to do this, we can just kind of remember our long division. So for example, if I have 123 divided by 15 or something like that, let's go with 11. Okay, I can write 11 into 123. It goes in once, so I times 10. This is a tens place, so 10 times 11 is 110. Okay, so usually we just write like this, although we could write the 0 in there, but lots of people just like to hold the 0 like that. So we get 110 and 3 ones, and then this is our ones position, so I need 111, so this gives us a remainder of 2. Okay, so it goes in there 11 times, so 11 times 11 plus 2 equals 123. Okay, so this is how we do long division with numbers. We're essentially going to do the same thing with polynomials. And the place values really just represent powers of x. Okay, in fact, place value really is just powers of 10. Okay, so place value in long division with polynomials is just powers of x. So one thing we just want to make sure, we have all the place values for the x powers. Yeah, it looks like there's consistent. And to do this, we ask ourselves this question. Okay, what number times x equals 2x squared? Just like what we did here, some number times 11 gives us a number closest to 12. Okay, in that case, it was 1. Here, what's the number that gives us closest to 2x squared? Well, if I do 2x times x, I end up with 2x squared. Okay, but I have to remember I'm multiplying this whole thing, so it's 2x times x, 2x times 1, so I get plus 2x. Notice that the place value, or the powers, will line up if I do this properly. Okay, so I'm going to subtract this, so I end up with 3x, and I bring down the next place value of 1s. And I'll do the same thing. Some number times x gets me close to 3x. Well, that's going to be plus 3. So I go 3 times x is 3x. 3 times 1 is plus 3. And then I subtract those. I get a remainder of negative 4. So my remainder, I'm going to do this in remainder, a different color. Remainder, negative 4. So there it is. So I have this divided by this gives us 2x plus 3 with a remainder of negative 4. Now, this is how we do long division, but we also want to be able to put this into the division statement. So the division statement is this. The dividend, what we're dividing is our divisor times quotient plus remainder. So in this case here, our dividend was our original 123. Our divisor was 11. Our quotient was 11 here, and our remainder was 2 here. So what this says is that the answer, or 123, I write it like this, 123 is equal to the divisor, 11, times the quotient, 11, plus the remainder, which is 2. Okay, which is true. 11 times 11 plus 2 is my original 123. And so that's what we get here. So I know that x plus 1 times the divisor, the quotient, 2x plus 3, plus the remainder, negative 4, will get me back to 2x squared plus 5x minus 1. Okay, which is true. If I actually FOIL this out, that's going to be true. So this is what we call our division statement. And this is actually very important, because we're going to use this division statement to help us analyze a lot of things and solve problems. So this is a division statement written in its multiplying form. Okay, we can also write it in its divide form. So we can just show it as 2x squared plus 5x minus 1 divided by x plus 1. I have to divide everything by x plus 1. The x plus 1 cancels, so I'm just left with 2x plus 3 minus 4 is divided by x plus 1, so I get that. So this is the division form. And I'll just show you what this looks like here. In this form here, it would be the answer, when I divide 11 into 123, my answer is 11 plus my remainder 2 over the divisor 11, right? Okay, so that's the answer to the division. So 123 divided by, and this is like in fractions what we did in grade 8, 123 over 11 gives me 11 and 2/11. Okay, so this is the division form of the division statement. Okay, now I would highly recommend that we try to stick with this because it's much easier to use. Okay, so we should know something about these rational expressions as well. If I graph this function, the original division statement, and my quotient, okay, you're going to notice something. So let's graph it, put it in your graphing tool, and tell me what that looks like, and see if you see anything interesting that happens. And maybe kind of think, well, why may that be happening?